Hello everybody, I'm Roman Rodriguez and I'm teaching physics for grade 9 and 10. We are on chapter 8, work, power and energy, and this is lesson 3, and our topic for today is kinetic energy and potential energy. Now you know there are various types of energy, but all these energy basically there are in two forms. They all contain these two forms of energy, that is kinetic energy and potential energy. Kinetic energy can be defined as the energy possessed by virtue of its motion, and potential energy is the energy possessed by virtue of its position. We have a mathematical equation to calculate kinetic energy, which is half mv squared, and potential energy mgh. So in today's lesson, lesson 3, I will derive these two equations of energy, kinetic energy and potential energy. So first I will prove that kinetic energy is equals to half mv squared. Okay. Now you know that the ability of a body to do work is called energy. Okay, and work can be defined mathematically as force into distance. Okay, this is what work done or work is equals to force times distance. Now, and according to the third equation of motion, we know that 2as is equals to vf squared minus vi squared. This is according to the third equation of motion. This is our second equation. Okay. Now we need to find the value of s from here. So I will so that we could substitute in equation number 1. So I'll move 2a on the other side. I'll get s is equals to vf squared minus vi squared upon 2a. Okay. In some books you will find that Vf, which is your final velocity, is taken as V, and Vi, which is your initial velocity, is taken as U. Doesn't matter, right? So suppose if I use this, then I'll get S is equals to V squared minus U squared upon 2A. Now, when a body starts from rest and it is in motion, it is moving, it starts its initial velocity, that is U, is equals to 0 when a body is at rest. And when it is moving with a velocity v. So if I substitute the value of u as 0, I'll get s is equals to v squared upon 2a. Right? Now, I've got this equation. What I will do is now, I will replace this value of s with this. So, what will I get? Let's call this equation number 3. So I'm substituting it in the first equation. First equation, you know, is W is equals to F into S. And if I substitute this value over here, I'll get W is equals to F times V squared upon 2A. Right? Now, what do we do with this force? Force, you know, is equals to mass into acceleration. Okay? According to Newton's second law of motion, when an external force acts on a body, it accelerates in the direction of the force, and the magnitude of the force is directly proportional to its acceleration. So what do I do now? I've got 3, equation number 4. I'll substitute this value of F is equals to ma over here in this equation. So this will become W is equals to ma times V squared upon 2a. Right? V squared upon 2a. So now, this a and a will cancel, so I can write this equation as W is equals to half mv squared, and I told you that work, the ability to do work is called energy. So I'm replacing this W with energy, that is kinetic energy we are discussing, so this will be equals to half mv squared. So here we have just proved that kinetic energy is equals to half mv squared. Okay, using this formula, that is work done is equals to force into distance, using the third equation of motion, 2as is equals to vi squared minus vi squared, and using the second law of motion, F is equal to ma. Okay, we conclude that kinetic energy is equals to half mv squared. Now let's go on to the next derivation. I'll prove that potential energy is equals to mgh. Now we know that potential energy is the energy possessed by virtue of its position. Position meaning you take a body which is over here, okay, and to a certain height. Let's say to this point, 0. Okay. Now, this is the height that we've taken up, maximum height. Over here, remember the body is at rest. So the kinetic energy will be 0. Okay, and the potential energy will be maximum over here. But when it is coming down, what will happen is that its potential energy will decrease, the height decreasing, till it becomes, when it hits the ground, the kinetic energy will be maximum and the potential energy will be 0, because there is no height. Height is 0. Here it is at rest, so velocity is 0. Here the height will be 0, so the potential energy will be 0. This is a very important thing that you need to know. Now the force that we have taken it from the body to move up over here is against its gravity, g. So I can write this starting from the same equation, how I started with the k is equals to half mv squared when I was deriving this. So w is equals to force into distance, and here distance we are replacing it with height, h. So I'll get this equation as work is equals to force into height. Okay, and now this force is obviously against the gravity. This, you know, F is equals to ma. So ma times h. Since force is equals to mass into acceleration, using Newton's second law of motion, and this is due to gravity, so I'll replace A with G, because the force with which it is moved up is moving against the gravity, it's coming down also with the gravity, so I'll replace A with acceleration due to gravity, which is G. So I'll get W is equals to mg times h. Hence, the ability for it to work is called energy. Replace this with potential energy that we are talking over here, with respect to that, is equals to mass times acceleration due to gravity times height. So there you go. So I've just proved the potential energy is equals to energy. So I hope it is clear to you all, and hope to see you in the next lesson. Till then, take care.